Good morning, everyone. Shall we begin the session? Yeah, I know this is 10 minutes prior, but I want to know only whether we start or we should wait for 10 minutes more. Okay, we'll wait for 10 minutes more till 4:30. Yeah, as far I guess. Now let's start the session. Next topic is the basic concepts of the OOPS, that is object-oriented programming. So it is necessary to understand some of the concepts used extensively in the object-oriented programming, and some are defined, some are not defined, so that must be captured, that must be used within the programming language, that must be defined within the programming language. So that includes the object, that includes the classes, that includes the data abstraction and the encapsulation, that includes the inheritance, polymorphism, dynamic binding, message passing. These are the various objects, these are the various concepts used in the object-oriented programming. Let's start with one by one, that is objects. So when we talk about the objects, that are the basic runtime entity or the live entity that is used in an object-oriented system. They may represent a person, place, bank account, table of data, or any item that the program has to handle. So whatsoever the data they have, whatsoever the profile they have to handle the data. They also must also represent the user-defined data such as the vector, time, and the list. And programming problem is also analyzed in terms of the objects and the nature of communication between them. So whatsoever the communication we have, whatsoever the data we have, that must be established, that must be used to communicate between them. And program objects should be chosen such that they match closely with the real-world objects, and that may take an associated address like a record in the Pascal or a structure in C. And whenever a program is executed, the objects interacted by sending the messages to one another. So if a program, or for example, if a customer and account are two objects in a program, then the customer must have a database, must have a or send a message to the accountant or account object requesting for the bank balance. And each object contains data and a code to manipulate the data. So whatsoever the object they have, whatsoever the interaction they have done the interaction without having to know the details of each other data or the code. And it is sufficient to know the type of the message accepted, type of the response returned by the objects, although different authors represent them differently, so that also shows the two notations that are properly used in the object-oriented language analysis and the design. So whatsoever profile they have, whatsoever the data they have, they must be chosen by the detail, they must be chosen by the variety of the details. So this is the class example, this is the object student. Data are the name, date of birth, marks, functions are the total, average, and the display. Yes, two functions are defined over here to know the what are the various data members or what are the various functions. That is the member function that is used with the object student. No, no, no. These are the objects already defined in the object. They are the processes that the customer has to pay for the bank balance. And they must be tracked, they must be used with the two notations that they properly or popularly used in the object-oriented analysis and the design. Then next is the classes. So whatsoever the objects that they have, that they contain the data and the code to manipulate that data, that requires with the set of the data and the code of an object that can be made a user-defined data type. So whatever the code they have, whatever the objects they have, they must be defined, they must be used as a user-defined data type with the help of a class. And in fact, whatsoever the object they are using up, they are of the type class. So in simple terms, objects are the real-time entities that is used, and the classes are the collection of the objects. When we collect the multiple objects together, that is stored in a class. So this is a collection of the objects of the similar type, not different type, but the similar type. Yeah, next topic is the data abstraction and the encapsulation. Now the next part is data abstraction and the encapsulation. So whatever we wrap within the class, that is known as encapsulations. The wrapping of the data and the functions into a single unit, that is known as the class, is known as encapsulation. So data abstraction is the most striking feature of the class. So whatsoever the data we have used up, whatsoever the profile we have used up, that is known as the data encapsulation. And the data is not accessible to the outside world, and only those functions which are wrapped in the class can access it. These functions provide the interface between the object data and the programs, and whatsoever the insulation they have, whatsoever the profile they have, they must use the insulation of the data from the direct access by the program, that is known as the data hiding or the information hiding. There are two concepts again. They are the data hiding or the information hiding. That is also known as abstraction. So that refers to the act of representing essential features without including the background details or the explanations. So whatsoever the profile we have, whatsoever the data we have, that will be used to include the background details or explanation. That classes use the concept of abstractions that are defined as a set of abstract attributes such as a size, weight, and cost, as well as the functions to operate on these attributes. And whatsoever the data they have, whatsoever the profile they have, they must be encapsulated. They must be combined together to hold the information. And function that operates on these data are known as the member function or the methods. So there are two parts. One is the member functions with the method. One is the data or the data members. And since the classes uses the concept of data abstraction, they are also known as the abstract data type or the ADT. Next concept is the inheritance. So we have done with abstraction, we have done with encapsulation, we have done with the object and the classes. Next part is inheritance. As the name advises, inheritance, that means acquiring the properties of one part, one term into the another. Like, yes, like the parent's heredity into the son or the daughter. In the same way, inheritance is the process by which the objects of one class acquires the properties of another class. It supports the concept of hierarchical classifications. For example, the bird robin is a part of the class flying bird, which is again a part of the class bird. And the principle behind this sort of division is that each derived class share common characteristics with the class. Whatsoever the data they have, whatsoever the profile they have a common characteristics with which it is derived, with which it is used. Yes, so inheritance is the way by which the object of one class acquires the properties of another class. Now, the another class that is derived is known as the derived class, and from where it is derived is known as the base class. In OOPS, in object-oriented programming, this concept arises, inheritance concept arises because of the idea of the reusability. This means we can add additional features to an existing classes without modifying it. And this is possible by deriving a new class from the existing one. And whatsoever the new class we have, that will have a combined features of both the classes. Real appeal and the power of the inheritance mechanism is that it allows the programmer to reuse a class, to reuse a profile that is almost the same, but not exactly it wants, but not we can say carried out their want that what he wants and to tailor the class in a way it does not introduce any undesirable side effects into the rest of the classes. So inheritance provides the reusability, inheritance provides the combined features of both the classes that have a mechanism, that have a profile pictures, that we want to know that it will be used to introduce or it does not introduce any undesirable side effects into the rest of the classes. Yeah, whatsoever the feature they have, whatsoever the data they have to provide these mechanisms directly to the programmer to reuse a class that is almost done, but not exactly what he wants. But he wants to tailor the class in such a way that it does not introduce any undesirable side effects into the rest of the classes. So this profile must be, we can say, the use to define the reusability of the code. Now the next part is this is the subclass that is defined. Subclass is also known as the derived class that defines only those features that are unique to it. Without use of the classification, each class would have to explicitly include all of its features. So this is a bird, this is the attribute, this is a feather, this is the labors, then flying birds, attributes, non-flying birds, attributes, then robin, swallow, penguin, and kiwi. So these are the few subclasses that is derived from the class bird. Bird have some attributes, bird have feathers, bird have lay eggs. In the same way, flying bird also have, non-flying bird also have. In the flying bird, there are two parts, robin and the swallow. Non-flying, again there are two parts, penguin and the kiwi. Now, next part is a polymorphism. So this is an example that shows how the inheritance works, or what is the use of inheritance that works for the profile, that works for the data, that includes a bird, flying bird, non-flying birds, robin, swallow, and so on. Next is the polymorphism, that is another important tools concept, but this is a Greek term that is used to take more than one form. Yeah, this is a Greek term, we can say. So this polymorphism means more than one form. So whenever we are using the operations, whenever we are using the coding for the for any operation that is a different instance, and the behavior that depends upon the type of data it is used in the operation. For example, consider the operation of the addition. For the two number, the operation includes will generate a sum. For example, if the operands are the strings, and then the operation will produce a third string by the concatenation. We concatenate the string, we combine the string by with the third string. And the process of making an operator to exhibit the different behaviors and different instances is known as the operator overloading. Yeah, when I combine multiple operators, when I use multiple operators together, that is known as operator overloading. In the same way, yeah, there is a function overloading that I told you. In the same way, there is a function overloading for the operator overloading. So there are two parts. So this figure illustrates that how a single function name can be used to illustrate or handle the different number and the types of the argument they have. This is something similar to the particular word that is having the several different meaning depending on the context. And using a single function name to perform different types of tasks is known as a function overloading. As I told you, there are two parts, function overloading and the operator overloading. Function means we are using the same function name at two places with a different argument list. Operator overloading means we are using the two or three operators at the same place with a different argument. And polymorphism also plays an important role in allowing the objects having the different internal structures to share the same external interface. This means that a general class of operations may not be accessed in the manner, even though specific actions associated with each operation may differ. And this polymorphism is extensively used in implementing the inheritance. This is a shape, this is a draw, circle objects, block objects, and the triangle objects. In the circle object, there is a draw circle, box object, there is a draw box, triangle object, there is a draw triangle. Now the next part is the dynamic binding. That means wrapping up, that means including up, that means executed with the profile, and these are also known as the late binding because this is used at the time of execution. At the time of execution, that means the code associated with the given procedure call is not known until the time of the call of runtime. It is associated with the polymorphism and inheritance, and whatsoever the function call associated with the polymorphic reference, that depends on the dynamic type of that reference, that depends on the feature that they have, objects that they have, process that they have, and they also draw the procedure that is to be redefined in each class that defines the object. And at the runtime, the code matching the object under current reference will be used. Next is the message passing. So it consists, or the object-oriented program also consists of a set of the objects that communicate with each other. And the process of programming in an object-oriented language therefore involves the following basic steps. Creating the classes that defines the objects and their behaviors, creating the object from class definitions, establishing the communication among the objects. So first is how to create an object that defines how to create the classes that defines the object and their behavior. Next is how to create the object from the class definitions. Next is establishing the communication among the objects. So they are the least further part that is used to send and receive the information. And the message for an object is a request that will be given for the execution of a procedure and therefore will invoke a function in the receiving objects that generates a desired result also. That requires a name, function object, message passing that will be sent. So whatsoever the message that they have, whatsoever the profile that they have, that is a request for execution of the procedure and therefore will invoke a function of the procedure in the receiving object that generates a desired result. And message passing involves specifying the name of the objects, the name of the function, that may be a message, and the information to be sent. So there are three parts over here: name of the object, name of the function, and the information to be sent. These profiles will be given. This profile will be given as the name of the function. There is employee.salary, name, object, message, information. So objects also have a life cycle. They can be created and destroyed, and the communication with an object is feasible as long as it is alive. So as long as it is used, they are alive at the doorstep that will be used to communicate with it, that will be used to communicate with the feasible solution that they have. This example says employee.salary, that means they are fetching out the salary from the employee and the name. There are three parts: object, message, and the information. These three parts are used as an execution of a procedure. Invoke a function procedure in the receiving object that generates a desired result. And the message passing also involves specifying the name of the subject, name of the function, and the information to be sent. Next is benefits of OOPS. But I'm not going to start right now because 4 minutes left for the class. So let's finish this class over here only. If there is any doubts, any clarifications, you can ask the doubts. Anything that you want to ask. So in today's class, we are finished with the features of the OOPS, basic concepts of OOPS, that may be object, classes, reference, enumerators, and so on. So these are the various benefits that we will. These are the various features, basic concept that will be available. So if I compile, one is object, then next is a class, next is the data abstraction, next is encapsulation, inheritance, at last is the dynamic binding. And the message passing, yes, last one, polymorphism, inheritance. Alright. Anyone, any doubt till here regarding the assignments, regarding these features, anything that you want to ask? These features are, we can say, the building blocks of an OOPS. Without these features, we cannot, we can say, we cannot use, or we cannot go through the program. So if we are not able to learn these, if we are not getting these, so it is very difficult to cope up with the terms, technologies, coding, whatsoever it is used in it. Yeah, this is as per the basic concepts of the base of the OOPS, we can say. Because, for example, if I take example of the polymorphism, that means, yeah, more than one form. If I use the same function name at two places, how you judge which function will be used or called at what time? That judging will be scheduled, that judging will be handled out by the polymorphism, by the OOPS. So this is the first concept, that is, yeah, that is a part of the OOP. So these are the basic runtime entity that will be defined in an object-oriented system. But yeah, and benefits are totally different. When I compile, or when I use these concepts into the programming, how these concepts will be handled out, or how these concepts will be used to generate a code that will be helpful to make any project. So they are totally different concepts.